Hello guys, in this video we are going to discuss the solution of the problem minimum sum. So let us look at the problem statement. The problem statement says given an array ARR such that each element is in the range 0 to 9, find the minimum possible sum of two numbers formed using the elements of the array. All digits in the given array must be used to form the two numbers. Return a string without leading zeros. So for instance, if this is the array which is given to us, the minimum possible sum of two numbers would be given by 358 plus 246 and the sum will be 604. This is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, first what we need to do is, given the array, we need to obtain two numbers. And these two numbers are such that the sum of these two numbers is minimum. So the first thing which we have to understand is, how do we find such a number, or how do we find such two numbers whose sum is minimum? Once we have found out those two numbers, all we have to do is we have to add those two numbers and return our answer. So first let us discuss how do we obtain two numbers such that the sum is minimum. So for that, let us take an example. So let us say this is the array which is given to us. So given an array, if we have to form a minimum number, then the minimum number can be found by arranging the elements of the array in ascending order. So what do I mean by this is, so let us say the array which is given to us is this. Now the minimum number which we can form from this array is 1, 2 and 3. As you can see over here, we have arranged the array in ascending order. Similarly, let us say we have to form two minimum numbers. So in such case, all we have to do is, first we have to arrange the array in ascending order. So let us say the array which is given to us is this, and then let us arrange this array in ascending order. So the array will look something like this. And then in order to form two minimum numbers, let us say those two numbers will be given by num1 and num2. All we have to do is we have to alternate between the elements of the array. So for instance, in num1, the number will look something like this: 2, then 4 and 6. Similarly, for num2, the number will look something like this: 3, 5 and 8. So over here, as you can see, I'm just alternating between the elements of the array. And in this way, we will be able to form, or we will be able to obtain two minimum numbers from the array. Once we have obtained these two minimum numbers, all we have to do is perform the sum operation. Now since the array could be very large, because of which the number 1 and number 2 will be very large, because of which what we are going to do is we are going to perform digit sum, and we are going to store digit sum into an array, and towards the end we are going to convert our output array into a string and return that string. So that's the general idea behind solving this problem, folks. Now let us discuss one corner case, and then we will discuss the pseudocode of this problem. So to discuss the corner case, let us take an example. So let us say the array which is given to us is this: 5, 3, 0, 7 and 4. After sorting this array, the array will look something like this. So this is the sorted array, and using this sorted array, if we have to form our two numbers num1 and num2, then those two numbers will be 0, 4 and 7, and for num2 the number will be 3 and 5. Now as you can see, there is a leading 0 over here. So this leading 0 we have to eliminate it. So this essentially should be treated as 47, and then all we have to do is perform the summation of 47 and 35. So the corner case just deals with removing these zeros from MSB. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to obtain minimum sum and an array is given to us. So for this, what we are going to do is we are going to first set n, which is equals to length of array, and then we are going to sort the array in descending order. So let us sort it: arr.sort and reverse equals to true. And once we have sorted the array, in order to avoid corner case, what we are going to do is we are going to remove all zeros from our array. So for that, all we have to do is, while array arr n-1 equals to 0, all we have to do is we just have to reduce the size of array by 1. Please note, we are not actually removing any element, we are just reducing the size of the array so that we will operate only on the non-zero elements. Once we have removed all the zeros from our array, now let us perform the sum operation. For that, let's have carry equals to 0 and an answer list. After that, let us iterate on the elements of the array. So for I in range of 1 to n and increment of 2. So the sum will be given by ARR I minus 1 plus ARR I. And that is the reason, folks, I have started the range from 1th element. And then let us add carry to this. And in this way, we will be able to obtain our digit sum. Once we have obtained our digit sum, let us push this digit sum onto our array. So for that, all we have to do is answer.append s modulo 10. Folks, please note over here we are performing s modulo 10 because we just want to push digit rather than its carry. After doing that, let us update the value of carry. So if let us say the sum is greater than 9, then in such case carry will be set to 1, otherwise carry will be set to 0. And folks, in this way we will be able to perform the sum of two numbers. And after performing the digit sum, towards the end we just have to check whether it is an odd length array. If this is an odd length array, then in such case the last digit has not been used so far, because of which we are using the last digit by appending it to our answer. And towards the end, let us check if carry exists. And if carry exists, all we have to do is we just have to push carry onto our answer. So answer.append carry. And folks, if you see this logic, in this logic we have created our answer array such that our least significant bit is at the beginning of the answer array. So when we will convert this into a string, all we have to do is first we have to reverse this answer list and then convert it back to the string such that the LSB will be towards the end of the string. So let us do that. So for that, all we have to do is we just have to return join and let us reverse the list. So reversed answer. And in this way, we will be able to perform the minimum sum. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. Over here, n is equals to length of array. Then we have sorted the array and then we have skipped all zeros. Once we have skipped all zeros, then we are setting carry equals to 0 and we are taking answer list and we are iterating on the elements of the array. First, we are computing sum, which is equals to ARR I minus 1 plus ARR I plus carry. And then we are pushing this sum onto the answer list. If sum is greater than 9, then carry has to be set to 1. Otherwise, carry will be 0. Towards the end, we are checking whether it is an odd length array. If this is an odd length array, then carry will be updated by the last digit which we have not used. And if carry is set, then we are pushing carry onto our answer list. Towards the end, we are reversing the answer list, forming a string and returning that. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. N equals to size of the array. Then we have sorted the array in descending order. Then we have skipped all zeros. Then a vector output. Carry equals to 0. We are iterating on the elements of the array. First we have computed sum, which is equals to ARR I minus 1 plus ARR I plus carry. Then we are pushing that sum onto our output. If sum is greater than 9, then carry has to be set to 1. Otherwise carry equals to 0. If it is an odd length array, then carry will be equals to ARR n minus 1. And then we are checking whether carry exists. If carry exists, then output dot push back carry. And towards the end, we are just reversing the list, forming our answer and returning it. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.